This vehicle is a 2013 Kia Forte. Now the client's concern for this one is that the ABS, traction light, and the parking brake light are on. So we're going to start the vehicle. And as you can see, ABS, traction control, and parking brake light are on. So we're going to get started with diagnostics. And we're going to use an hotel. And we're going to see what we have here. We're going to go diagnostics. We're going to go VIN. We're going to go auto detect. So what module are we mainly concerned with this one? I have no check engine light on or anything, so I am mainly concerned with my ABS module onto this one. It's always a good idea to do an auto scan, but for this one, we're going to go just ABS. We're going to go recodes. We're going to save that also, so I can print that out after. Oh boy. Alright. Ecu Hardware Error. We have a CAN timeout for the steering angle sensor. That is not looking good, eh? Left rear, left front, and active. So I have two that are active. So we have the left rear vehicle speed sensor that is active, and we also have the left front vehicle wheel speed sensor that is active. So this is going to be a pretty standard check. I'm guessing we're going to take in, we're going to scope the sensors at the same time, and we're going to see what type of signals we should have. I'm going to pull up some details. If I'm not mistaken, these ones are magneto-resistive, so they should be generating their own voltage, but don't quote me on that yet. I'll go and I'll get all the specs for us at the same time. So I'm going to pause you guys, and then I'll bring you guys back under the vehicle. Alright, so the first thing that we're going to do is I just raise the vehicle a little bit. We are going to back up. We're going to go into live data. We are going to go onto our wheel speed sensors. We're going to pick all four. And with all four there, I'm going to go and I'm going to start spinning the wheels one by one. And we're going to see if we have any change. First, I'm going to start with the front left, the front right. Now, while I spin the front right, we should see a change onto the front left also. As you can tell, I didn't see a change there, and I'm going to go spin the rear right, and then I'm going to go spin the rear left. So, as you can see there, my rear right had a signal coming off of it, where my rear left did not. And when I spin my front right again, we see that there is no change to my front left. So we obviously have an issue onto the left-hand wheel speed sensors. So now what we're going to do is go get some data for the DTCs, and then we will be testing onto the vehicle. Alright, so I have everything set up onto the scope right now for you guys. And right now I am hooked onto the front right sensor. Now, there was no issue with the front right sensor, and that's why I'm hooked up to it first, to show you guys what a good working sensor on this car looks like. Now, I was wrong in stating that this was a magneto-resistive sensor. This is an active Hall effect sensor, so the signal that we should be looking for is a square wave. Now, on Kia vehicles, what ends up happening is that the ABS module sends out a 12-volt voltage. Now that 12-volt voltage is on my channel A, which is this red one. And the 12-volt voltage is your power feed for your ABS sensor. Now, my green trace is hooked up to my signal voltage. Now my signal voltage is also my ground for the sensor. So now what ends up happening is when the key is turned on, the ABS module sends a check voltage through up to the sensor and sees for a response back. And that's why we are seeing a green trace down here with, I think, about 800 millivolts. We'll change this to a 10 to a we'll go to a 5-volt scale. There. So we are seeing roughly about 800 millivolts. 691 millivolts. Now, as long as the system is working properly, you will have your constant 12 volts, and you will have roughly about 600 millivolts onto your signal feed at all times. Now, what ends up happening is that when you spin the wheel, I'll change this back to 20 volts. Your signal voltage will start to get a square wave, and your 12 volt feed will also get a square wave put onto it, but they will be reversed, and I'm going to show you guys that right now. We'll stop that. Okay, so like I said, your signal will get a square wave onto it, and your voltage will also have a square wave. Now, it's important to see right here that your square waves are actually opposite of each other. Okay? Now, it kind of looks like a CAN signal there, but it's actually your ABS signal. So, this is what a good working sensor looks like onto these cards. Now, I'm going to show you guys the bad sensor. Well, the sensor that's not operating. And we're going to go through some checks onto the bad sensor. Alright guys, so now we're on to the bad, the wheel that's giving us the fault code. Now, on this one, what we're going to do is we're going to do a quick check to make sure that we actually have our 12 volt pulse that comes from the ABS module, which is basically a check to make sure the system is okay. And after it senses that the system is okay, it takes and it adds that 12 volts onto the feed wire constantly. Now, it's important to remember that the 12 volts that is onto the voltage wire is not a real 12 volts. So if you guys try to use a test light, you guys will bring this the signal down to ground, and you will get a short or open DTC as we have right now onto the system. So I'm going to show you guys how to test this with a test light and with a scope at the same time. Alright, so I have everything hooked up onto my sensor right now, and what we're going to be doing is taking and erasing the DTCs out of the system. So for this, unfortunately, you are going to need a second scan tool, or maybe the Handtech or another scope in order to do this properly, in order to verify your signals that are onto it. So as you can see right now, my red trace, which is my voltage signal, is at 0 volts, and my signal trace, which is this green one, is also at 0 volts. Now, if you remember onto the working sensor, my voltage trace was at 12 volts and my signal trace was at 0.6 volts. So I'm going to take and I'm going to erase the DTCs out of the system right now. Now what you're going to see is a pulse onto my voltage side and no pulse onto my ground side or my signal side. So I'm going to go and I'm going to erase them now. We're going to watch. And as you can see there, we have a pulse up to battery voltage. Now what does that indicate? That indicates that everything from the module onto the voltage feed side all the way up to the sensor is good. Up to the sensor connector, I should say, is good. So if I would come onto my wiring diagram, I basically just tested from here, VCC, all the way up to here, where my pin 2 is. Now this is where my ABS connector is, sensor connector is. So now that I know that my ABS module is able to send out its pulse signal in order to verify the integrity of the circuit, I'm going to show you guys with a test light, an LED test light. Remember, this exact same test. I'm going to show you guys the exact same test using an LED test light now. So my VCC wire. Oh, I'll try to get you guys in here. All right. So my VCC wire is this black with red, which is this guy right here. Now what I'm going to do is just take my test light, my LED test light. I am going to probe onto there. I'm going to bring him up here. And now what I'm going to do is erase the DTC. Now what you should see is a pulse. I'm going to erase them now. And we're going to look for a pulse. I didn't see a pulse. Did you guys see a pulse? It's going to make a liar out of me. I'll retry that again. Make sure I actually got it. Erase all DTCs. And as you can see, that pulse is sent out from your ABS module, and you can check it with an LED test light hooked up to ground. Alright, so now that we know we have our 12-volt signal pulse that's coming out from the ABS module, that tells me that my ABS module is more than likely has good integrity. Now, there's no way to tell if the signal is good onto the signal side, because as soon as there's a code set, it cuts power to your ABS sensor. So the easiest way that I found to do this is actually take and go onto a sensor that is working properly, use the connector that's coming from the ABS module onto the bad sensor, and connect that to a known good sensor onto the vehicle. And that's what I'm going to do right now for you guys. And we are going to go to Diagnostics. Alright, I'm just going to wait for my VCI to load up now. Alright, so I had to restart the MaxiSys, so what we're going to be doing now is rescanning the vehicle. And we're going to go in and we're going to recheck for DTCs. Now what I ended up doing was taking the connector from the ABS sensor that leads to the ABS module, and I took that connector and I hooked that up to my front right ABS sensor. My front right ABS sensor. So my front left ABS ECU connector is hooked up to my front right ABS sensor. And the reason I'm doing that is just to do a quick validation on if my circuit is good. Because if my DTC changed, and now I have a front right ABS code and a rear left ABS code, that means that my issue is into my sensor onto my front left. And as you can see here, my front right vehicle speed sensor has a fault now because it is unplugged, and my rear left speed sensor has a fault because I haven't diagnosed it yet. So what does that tell me? My wiring from my from the ABS sensor all the way up to the module is good and onto my left hand side, and the issue is into my sensor. Now I have to take and redo all these same tests for the rear right ABS sensor, and then I will be done this diagnostics. So I hope you guys enjoyed this little video, and I will be seeing you guys next time.